Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I am doing, please don't forget to share my videos to your friends and to your friends' friends. And also, don't forget to subscribe. That's the only way you can help me promote my channel and to refresh and keep me going of this very tiring work. Determine the horizontal displacement at B by virtual work method and at D by Castigliano's second theorem. Take modulus of elasticity 200 gigapascals and moment of inertia 180 times 10 to the 6 millimeter to the fourth. So by virtual work method, the horizontal displacement at B, so we apply a unit rightward force at horizontal force at B. So reaction summation moment at A equals 0, RD times 9, RD times 9 equals 6 times 6 plus 1.2 times 9 times 4.5. So reaction at D, which is vertical, is equal to 9.4 kilonewtons as shown. So we don't need the reactions at A because we plan to section each segment of the frame considering forces to the right and below the section only. Although you can shift sections if you want by computing reactions at A. So to be consistent, we'll just consider all forces to the right and below the sectioning in the following manner. So take note that the moment of inertia of CD is 2I, but because the moment of the actual reactions about this point is 0, because that's vertical, so it has no contribution. It has no moment contribution. So there are 4 segments, but we can reduce that to just 3 because for CD, moment is 0. Then due to virtual forces, we apply a rightward unit load at B, then compute reaction at D. Reaction at D times 9 equals 1 times 9. So reaction at D is 1, also 1, as shown. And the moment is also 0 for CD. But for the other segments, there is. So EI delta B horizontal equals integral from 0 to 3. So we begin with this because this is bypassed because the moment here is 0. So 9.4 times x, that's the big M. Then small m is 1 times x, dx 0 to 3. Then next in this section here, plus integral 0 to 6. The moment is 9.4, positive 9.4, times quantity 3 plus x minus 6x, that's the big M, 0 to 6. Small m is 1 times 3 plus x only. Then dx over 1. And lastly, in this section, the moment here is big M is 9.4 times 9. That's the moment arm 9. Minus 6 times 6. Then minus 1.2 times x over 2. So simplifying, integral from 0 to 9 of 9.4 times 9 minus 6 times 6 minus 0.6 x squared, where 0.6 x squared is 1.2 times x over 2. Then due to virtual forces, 1 times 9 minus 1 times x only, dx over 1. So integrating, the first integral is equal to 84.6. The second is 1443.6. And the third is 1640.25. Combining, delta BH is 3168.45 over EI, where EI is 200 times 10 to the 6 times 180 times 10 to the 6 divided by 1000 to the 4th, or simply 200 times 180, that would be 36,000 kilonewton meter square. So to convert this to millimeters, our experience suggests that we just divide this by 36. So delta BH is 3168.45 over 36. So delta BH is 88.012 mm rightward. Then by Castigliano's second theorem at D, we apply a force P at D horizontal to assume that the displacement is rightward or positive, as shown in the figure. So same sectioning. There is moment here, but the partial derivative is P is X, but P is 0, so the result would still be 0. So RD times 9 equals 1.2 times 9 times 4.5 plus 6 times 6 plus P times 4. So this is 4. 9 minus 5, so 4. So R sub D is equal to 9.4 plus 4P over 9. So let's put it there as our guide. So EI delta D horizontal equals integral from 0 to 3. So we bypass this part because the moment here is just px, derivative x dx, but p is 0, so it's still 0. So we begin with this section. The moment there is quantity integral quantity 0 to 3, 9.4 plus 4p over 9 times x, then plus p times 5, then the derivative is 4x over 9 plus 5 dx over 1. Then in this section, the moment is integral from 0 to 6 of quantity 9.4 plus 4p over 9 times 3 plus x plus p times 5 minus 6x. Then the derivative is 4 over 9 of 3 plus x plus 5 dx all over 1. And lastly, in this section, integral from 0 to 9 of quantity 9.4 plus 4p over 9 times 9 plus p times, so this is 5 minus x. If that is x, so this is 5 minus x plus 6 times 6, because this is 6 meters. So integral 0 to 9 of 9.4 plus 4p over 9 times 9 plus p times 5 minus x minus 6 times x minus 0.6 x squared. Then times derivative 4p over 9 times 9 is 4. Then derivative of p times 5 minus x with respect to p is 5 minus x. Or simply this is 9 minus x. So integrating, this reduces to integral from 0 to 3 of 9.4x times 4 over 9x plus 5. So the integral, the first is 249.1. The second, integral 0 to 6 of 9.4 times 3 plus x minus 6x close, then times 4 over 9 3 plus x plus 5, or you may simplify that using your stats and evaluate manually. So that's 1793.6. And lastly, integral 0 to 9 of 9.4 times 9, because this is set to 0, minus 36 minus 0.6x squared, then times 9 minus x. So the integral is 1640.25. Combining, delta D horizontal is 3682.95 over EI. So divided by 36. So delta DH is 102.304. mm rightward. So that's it for this problem.